Video opens immediately on a split screen. On the left, Warzone Mobile is running on a standard iPhone. The footage shows noticeable stuttering during a firefight. The player dies as the game lags at a key moment. On the right, the same game, same firefight, but the gameplay is perfectly smooth. You've got one of the most powerful chips in the world sitting in your pocket. But what happens when you fire up a serious game? What if the only thing standing between this laggy experience and this buttery smooth one is a risky modification that turns your iPhone into an absolute gaming monster? Today, we're going to do something a little nuts. We're going to say goodbye to overheating for good. For many, after 15 or 20 minutes, the phone gets hot, the screen starts to dim, and your frame rate takes a nose. Modern iPhones use a passive cooling system, meaning heat just dissipates through the frame and glass. There are no fans. When that system gets overwhelmed, the software slams the brakes on the processor to prevent it from cooking itself. Picture it. You're in the final circle in Warzone Mobile. It's you versus one other player. You have the drop on them, you line up the perfect shot, and the game stutters. They can lower the temperature and make a real difference in performance. But they don't solve the fundamental problem. They're cooling the outside of the phone. I'm not talking about a fan. I'm talking about performing open-heart surgery on an iPhone to install a custom, internal liquid cooling system. The fire is deep inside. On the chip itself, we're building a tiny, custom vapor chamber, the same kind of tech Apple is rumored to be developing. A vapor chamber is a hyper-efficient, passive heat transfer loop. It's a sealed chamber with a bit of fluid inside. We have to remove the screen, the battery, the most dangerous part, and finally, the logic board itself. With the board out, we can see our target, the A-series Bionic chip, the source of all that power and all that heat. When it gets hot over the processor, the fluid boils into a vapor. This involves creating two halves of a shallow, sealed chamber. Inside, we create a wick from micro-sintered copper powder, which is what allows capillary action to move the fluid. We run the 3D Mark Wild Life Extreme Stress Test, a brutal 20-minute benchmark designed to force thermal on the stock phone. The results are as expected. The stock iPhone's surface hits 44 degrees Celsius near the processor, getting almost too hot to hold. The gameplay is choppy. On our modded iPhone, the camera shows the heat is spread evenly across the back, with a max temperature of just 35 degrees Celsius. It's warm, but never hot. And the gameplay, rock solid. After laser welding the halves together, we use a syringe to inject a tiny amount of a special non-conductive fluid designed for electronics, cooling, and then hermetically sealed the port. The process was intense, and the risks were huge. But the result is a unique device that's objectively better for gaming. Apple's engineers balance power with aesthetics, durability, and battery life. They put a leash on the beast for a more predictable experience. We just chose to set it free. The fact that vapor chambers are even rumored for the iPhone 17 shows that Apple themselves are moving in this direction. We just got there a little early. That vapor rushes to the cooler parts of the chamber, condenses back into a liquid, and releases its heat. It's designed to spread heat to the phone's metal frame, turning the whole chassis into a radiator. Seeing the risks, the process, and these results. Would you ever be brave enough to try a mod like this on your phone? Or is the thought of bricking your expensive device just too terrifying? Let me know your thoughts in the comments below. I read every single one. Smash the like button, subscribe, and turn on notifications for more tech challenges, future experiments, and real talk from Tech Wave 65. Thanks for watching. Through a high-risk internal liquid cooling mod, we've created a phone that can sustain its performance like never before. We've eliminated the frustrating lag, stuttering, and screen dimming that plagues so many mobile gamers. We've shown that the raw power inside the A-series chip is there, just waiting to be unleashed. On the stock phone, after a couple of matches, the stutters are back. On the modded phone, we can play for over an hour straight with performance that feels just as smooth as the first minute. We've effectively broken the thermal barrier that was holding the iPhone back. We've built the gaming phone that Apple, in its pursuit of thinness and mainstream appeal, has so far refused to make. After meticulously rooting everything back into place, we reassemble the phone, hold our breath, and press the power button. If we did everything right, it will boot up as if nothing happened. But under the hood, the beast has been unchained. A wick structure then pulls the liquid back to the hotspot, and the cycle repeats endlessly. An external fan is like trying to cool a car engine by blowing on the hood. It looks and feels exactly the same, but its performance is now in a different league. To prove it, we need cold, hard data. The core issue remains. The heat isn't being moved away from its source efficiently enough. And that's what we're going to fix. It's just for a split second, but it's enough. Your input lags, and by the time the screen catches up, you're watching the kill you lost, not because of skill, but because your $1,000 phone needed to take a breather. There is a very high chance of permanently destroying your phone. It instantly voids your warranty, kills any water resistance, and one wrong move near the battery could be genuinely dangerous. Do not try this unless you re an expert who has accepted that your phone might become a very expensive paperweight. This isn't a tutorial, it's an exploration of what's possible when you push the limits. It seems Apple knows this is a pain point, as rumors are swirling that they're re-exploring more advanced vapor chamber cooling for the iPhone 17 Pro models. And if you're trying to stream your game, the combined load can turn your phone into a hot potato, making your stream a pixelated mess. This constant heat is also a long-term enemy of lithium-ion batteries, and chronic overheating can shorten your phone's lifespan. But that's a long way off, and doesn't help us today. It becomes a frustrating, laggy mess. This is thermal throttling. So, you just dropped $1,000 on a new iPhone. The graphics are incredible, the frame rates are smooth as silk, and it feels like the future. But then, you start to feel it. That warmth on the back of the phone, it builds into a serious heat, sometimes hitting an uncomfortable 42 degrees Celsius or more. Then, the first sign of trouble. The screen dims. That's Apple's software, hitting the brakes to manage the heat. But what if you could unlock the full, unrestricted power of your phone? Section 1. The problem. A powerhouse on a leash. Inside this sleek glass and metal sandwich is a chip that rivals some laptops in power. Apple gets on stage and shows off these amazing console-quality games, running flawlessly. They talk about teraflops and neural engines, selling the dream of a portable gaming console that can run titles like Assassin's Creed Mirage and Resident Evil. Your iPhone is a powerhouse on a leash. And for the first few minutes, that dream is real. This isn't a defect, it's a design choice. It's called thermal throttling. Section 2. The agitation. The gamer's frustration. This throttling isn't just a number on a chart. It's an infuriating experience that can ruin a great gaming session. This can happen across all sorts of demanding games. In Genshin Impact, a beautiful elemental burst can turn into a slideshow. You can try the usual fixes. You can buy a clip-on phone cooler. And to be fair, the good ones absolutely help. Section 3. The risky solution. The liquid cooling mod. This is where we go from enthusiast to mad scientist. Let me be absolutely crystal clear. This is an incredibly risky and difficult modification. So, what's the plan? Our mission is to build one that fits inside an iPhone. First, the teardown. It's a careful dance of penelope screws, adhesive, and impossibly fragile cables. Next, fabrication. Using precise measurements, we design our vapor chamber from a thin sheet of copper. Now for the point of no return, integration. We apply high-performance thermal paste to the chip and carefully place our custom vapor chamber on top. Section 4. The transformation and the proof. The phone boots up. First, the baseline with an unmodified iPhone 15 Pro. Now for our liquid-cooled monster, we'll run the same test. The first loop scores a similar 3,350. The 10th loop scores 3,340. By the final loop, the score is still an amazing 3,280. The performance stability? A near-perfect 98%. The phone barely throttled at all. It held its peak performance for nearly the entire test. But what about actual feel? We use a thermal camera while playing Genshin Impact for 30 minutes on the highest settings. Back to our first test, Warzone Mobile. Conclusion, and So, we did it. We took a standard iPhone, known for its thermal throttling under heavy load, and transformed it. Was it worth it? For me, as a tech enthusiast and hardcore gamer, absolutely. But this project also highlights the compromises in modern smartphone design. Now, I have to ask you the big question.